So, chapter 12. And this is the last chapter for the 163 class. So, vectors. And the magnitude of a vector. So the magnitude of a vector, whatever that vector may be, is going to be given by x2 minus x1 squared, y2 minus y1 squared. And if it's a position vector, it means that one point is at the origin. And so we have a vector v, which has coordinates v1, v2. Then the magnitude of v is just given by v1 squared, v2 squared, and take the square root of that. Right. So let's say we have two vectors. We have a vector u, which is minus 3, 4. We have a vector v, which is 5, 12. Okay. Well, with these vectors, we can do several things. Well, we can add these together. We can do u plus v, which will be the minus 3 plus the 5, the 4 plus the 12. So this will give us 2, 16. We could do u minus v, which will be the minus 3 minus the 5, and then the 4 minus the 12. So minus 8 minus 8. We can take a vector, we can multiply it by a constant. So I could do 4u, which will give us minus 12, 16. We could find the magnitude of u, which will be minus 3 squared plus 4 squared. And this will give us 5. We could find the magnitude of v, which will be square root of 5 squared plus 12 squared, and this will give us 13. We could also find the unit vector, which is given by the vector divided by the magnitude of the vector. So in the case of vector u, this would be the vector 3, 4 over 5, which would give me 3/5, 4/5. So now we can talk in terms of the x, y, z coordinate system. And so d is now going to be x2 minus x1 squared, y2 minus y1 squared, and then z2 minus z1 squared. So my distance formula. So in terms of equations, so we can have equation of a sphere, which is x minus a squared, y minus b squared, z minus c squared equals r squared. So that would be a sphere. And the center would be at the point A, B, C. And the radius is going to equal r. And then we could have this for a ball. And so basically it's the same equation, except for one little difference, and that occurs at the end. This is now less than or equal to r squared. Right? So a sphere is just the outside shell. The ball is a solid object. Right? And then we could also have a unit vector for A in terms of this. Right? Dot product. So vector u has the coordinates u1, u2, u3. Vector v has v1, v2, v3. Then u dot v is u1, v1 plus u2, v2 plus u3, v3. Right? So, for example, if we said u was the vector 4, 7, 8, and v was the vector 3, 5, 2, then my dot product is going to be 4 times 2, 7 times 5, and 8 times the 2. And we do that all out, we end up at 59 for that. Okay. And we can find the angle between the vectors. So the angle between our vectors is going to be theta, is going to be the inverse cosine of the dot product divided by the magnitude of u times the magnitude of v. So let's use the vectors we just had, my u and v. So we now need to find the magnitude of those two. So the magnitude of u would be 4 squared, 7 squared, 8 squared. So this ends up being the square root of 117. And then for vector v, my magnitude is, this will be 3 squared, 5 squared, 2 squared. And this will give us 38. And so theta is going to be the inverse cosine of 59 over the square root of 117 times the square root of 38. Okay. And so you could plug that in and get the answer for that. So let's see, inverse cosine. Cosine. And so this comes out to be let's call this 485, and this would be in radians, all right? Right. So we get that. All right. We could also find the cross product. So the cross product, u cross v, is equal to the magnitude of u times the magnitude of v times the sine of theta. And so here This, in terms of my current example, is the square root of 117 times the square root of 38 times the sine of 0.485. So we can plug that in and we can get that number. Times the square root of 38. And then the sine of 0.485. And this comes out to be 31.086, we'll call it. Right? So we get that number. All right. Oh, let's see. Other things in here we have in terms of an equation of a line. And so V, in terms of A, B, and C, and P naught, our starting point, in terms of, should be in parentheses. So X naught, Y naught, C naught, right? So RT is going to be R naught T times V. So given X, Y, Z is going to be X naught, Y naught, Z naught, plus T times so let's look at an example. So we want the equation. So we have P naught minus 3, 5, 8, and that is 4, 2, minus 1. So the direction V is equal to P naught P1 is going to be 4 minus the minus 3, 2 minus the 5, and minus 1 minus 8, which will give us 7 minus 3 minus 9. So R sub T equals R naught plus T times V. So this is minus 3, 5, 8 plus T 7 minus 3 minus 9. And so this will give us minus 3 plus 7t, 5 minus 3t, and then 8 minus 9t. Then we can find the unit tangent vector. And so is given by the derivative over the magnitude of the derivative. All right. So let's look at an example of how this would work. So given that RT of t is given by t squared for t for ln t. And t is going to be greater than 0. So my derivative is going to be 2t. This is going to be 4. And this will be 4 over t. So that's that part. Now we need to know the magnitude of this. So the magnitude of this is going to be 2t squared, 4 squared, 4 over t squared, which will be the square root of 4t squared plus 16 plus 16 over t squared. And this will factor to give us 2t plus 4 over t squared. And this will become 2t plus 4 over t. So that means my tangent vector is going to be 2t, 4 over t over 2t plus. So we get that. Well, let's see other things we can do. So let's say we can also integrate. So now we got t to the 4th minus 3t, 2t minus 1, and 10. So we can integrate this with respect to t. Oops, sorry. So this will give us t to the 5th over 5, and actually minus 3t squared over 2. This will be 2t squared over 2 minus t. Right? This will be 10t. Okay? Now again, this is indefinite integrals, so we now have that for each one of these we have a c. So we're going to say plus c1 plus c2 plus c3. Right? But then we can say, well, we'll just say c is going to be the combination of all these individual constants. Right? And so we end up with t to the 5th over 5, 3t squared over 2, t squared minus t, 10t, and then we have a plus c. So position, velocity, speed, and acceleration. So let's say the position is given by r sub t equals sub t, y sub t, z t. Right? And t is greater than or equal to 0. Right? Well, then the velocity, so v of t is going to be, velocity is just the derivative of the position, and so this will be x prime t, y prime t, z prime t. Right? And then speed is just the magnitude of my velocity. And so this will be x prime t squared, y prime t squared, and z prime. So we got position, we got velocity, we got speed, so that leaves acceleration left. And so acceleration, AT, is the derivative of my velocity, which is the second derivative of my position. All right. So let's look at an example of this. So let's say position function is given by this. 1 4t squared plus 3. And t is greater than or equal to 0. Right? So my velocity is this my derivative. So this will be 6t at. And then the magnitude of this is going to be 6t squared plus 8t squared is going to be the square root of 100. T squared is going to give 10t. And then my acceleration is going to end up being 6, 8. For that. All right. So then we get to arc length of a vector function. So L equals the interval a to b f prime t squared g prime t squared h prime t squared dt, which equals the integral of a to b of the dt. All right. So let's look at an example. So let's say that RT is given to be 2 plus 3t, 1 minus 4t, and minus 4 plus 3t. And we want t between 1 and 6. Okay? So that would mean r prime, my derivative, would have been 3 minus 4 and 3. And so then my magnitude of r prime would be 3 squared plus or minus 4 squared plus 3 squared, which end up being the square root of 34. And so we want to integrate from 1 to 6 the square root of 34 dt. So this ends up being the square root of 34 times t evaluated from 1 to 6. So this will be 6 square root 34 minus the square root of 34. We end up at 5 square roots of 34. And then lastly, finishes off with curvature. So t equals r prime over the magnitude of r prime. And then we can also write curvature is going to be this sort of a k thing of s dt over the d of s. And then they write this another way. It's 1 over the magnitude of v over d of t equals over r prime t. And then another way, so the other thing they give you is an alternative formula is that k is v cross a over v cubed. Right? And so v is r prime and a is v prime, right? And that will conclude this video.